Hello everyone. Today we are in the chapter 4 of 8086, which is Introduction to IBM PC and Assembly Languages. Assembly language is the language which is connected with some mnemonics or symbol or syntax. Assembly language programs are translated into machine programs instructions by an assembler. If you use an assembler, you can easily transform assembly languages to machine language, which is very closer to your computer. This assembly language is case sensitive and uppercase is differentiate code from the rest of the text. The statements. First of all, you have the name, which you can denote as a start. Operation can be moved. CX and 5 are the operands. And lastly, the comment. After a semicolon, you can write a comment. So here, name is a start, operation is move, operand is CX and 5, and then comment is the initialized counter. That's how the statement works. Here main is a name and operation field contains procs. There are some rules how to define the name field. Those are basically similar to the C programming rules. Here you can names can be start from 1 to 31 characters long, contains letter digit and special symbols. Embedded blanks are not allowed. If a period is used, then it must be first character. Names may not begin with digits. Here are some examples of legal and illegal names. And why they are illegal, their description is given here. In the operation field, we have the operation code, which is opcode, which can be add, move, subtraction, etc. In operation field, we write code like this one, like add, which is the opcode, and word1 is 2 is the operand. That's how the operation field works. In comment section, you need to use a semicolon. After a semicolon, you can write anything would be denoted as a comment. That's how in this code, this section is denoted as a code, but after the semicolon, move 0 to CX will denote it as a comment. That is how a comment field works. Program data. The processor operates only on binary data. Thus, the assembly must translate all data presentations into binary numbers. However, in the assembly program, we may express data as binary, decimal, hexadecimal, even such as characters. Now, numbers. A binary number is written as bit string followed by letter capital B or small b. For example, 1010B, a decimal number or a string decimal digit ending with an operation capital D or small d. A hexadecimal number must begin with a decimal number and ends with a letter which is capital H or small h. That is the reason we can see by this H that this one is a hexadecimal code. If you have D after your some uh, numbers, you can denote that this one is the decimal. By B, you can denote that this one is the binary one. This is how the number works. Here, this B denotes it is the binary. D denotes this is the decimal. H denotes this is the hexadecimal. Now characters. In these characters we have several types. Here we have DB for defined byte, DW for defined word, DD for defined double, DQ for defined quad word, DT for defined 10 bytes. Character schedules are important for your exam. You can have a snap of this one. Variables are memory locations. Those are denoted as byte variable, word variable, and array variable. Byte variable, those are assembler directive that defines a byte variable text following from name, then initialize the value, such as alpha is the name and db is the value. That is how we denote the byte variable. Now moving to the word variable. First name, then the initialized value. In here we have the name is wrd and then the value is -2. Here dw denotes the word, which can be from this section if it is signed, and if it is unsigned then it can be from 0 to 65535. Now we are in the array section. First of all, you need to define it as an array. Then db is for the byte section, and here we have the hexadecimal section. Here we have the array. This one is index 1, index 2, and index 3. By this table you can easily understand that this one is the symbol, or you can may say this one is a name. So this 200 is the address which contains 10 hexadecimal value. The next one is 201 contains 20 hexadecimal value. The next one, which is the memory location 202, which contains the 30h or 30 hexadecimal value. That is how the array is declared in the assembly programming languages. Now the higher and the lower bytes. Here you have 1234 hexadecimal value. The last two bytes are the lowest bytes and the first two are the highest one. So here the highest byte contains 12 and the lowest byte contains 34. Characteristics are not so much very important. You can have a snap or you can read it further, but we are now skipping this one. Equations are quite important. EQU used for equals, that means it is for the operations. Here we have move DL and OA hexadecimal, move DL LF. Here EQU is means the equal. Here you have name, then the constant. Here LF, here in this statement denotes that LF is equals to the 0A. So if you use the 0A or LF, it will do the same thing. So EQU means the equal or the same. MOV is used to move from source to destination. First you need to denote the destination, then the source. That means word 1 is moving to AX, not AX is moving to the word 1. xchg means the exchange. Here xchg AHBL means the BL is moving to AH. This is the exchange value. The value of BL is moving to AH and the value of AL is moving to the BL. That is how the exchange works. First of all, we have here A100 and under that 0005. After exchange we have 0500 and 00A1. So that is the value of exchange. Here are some legal combination operands for move and exchange. Here are some source of operation, which are general register, segment register, memory location and constant. Here are the conditions for general register to general register, segment register to segment register, memory location and constant. Here is the value of exchange. Here we have the general purpose registers and for the memory locations. Those diagrams are tables are very important for your exam point of view. Please have a snap of them. Addition, subtraction, increment, decrement are also the same as move function. Last you have the source, and right that you have the destination section. Add destination source means the source value will add it to the destination section, and in this section the source value will subtract from the destination section. This is a legal combination of addition and subtraction for general register, memory location and constant. You can have a snap of this one. In increment and decrement section, you just need to identify the increment or decrement, then the destination, because increment or decrement are moved value only one, so there is no source value. You have 0002, and right after the increment you have 0003. That means it just move one, and the increment is only one, so there is no source section. This memory model of 8086 is very important for your exam question point of view. First of all, you need to know that we have some types of model. Those are divided into 5 sections. Those are small, medium, compact, large and huge. First one is the small one. Small model, here in code we have one segment, in data we have one segment. That means code in one segment and data in one segment. But in medium we have code in more than one segment and data in one segment. Now in compact, here we have code in one segment but data in more than one segment. In the large section we have code more than one section and data also more than in one section, but no array is larger than 24 kilobytes. In huge section, the code is more than one segment and data is also more than one segment, but array may be larger than the 64 bytes. This memory section is very important for your examination. Please have a snap of this one. Now we are in the data segment. Here, to declare a data segment we use dot data then flow. Here firstly we denoted dot data, that denotes that this segment is the data segment. Then we write the code for the data segment. So full stop data denotes the data segment. Now we're in the segment section. In segment section it starts when you denote it as full stop or dot. After that you declared stack, then its size. In this section you can have that this one is for the declaration and the size is for the 100 hexadecimal. This one is for the stack segment. Right after that we have the code segment, which started as dot then code then the name of the code. So we have here the dot code. That means we are entering into the code section. Then main is the main function, and proc is the name of the program. End main is denote for the for the end or uh, elimination of the main function. After putting together all of those values, we can have this type of code. By this code, you can easily understand that here by this code the model is small. That means it does not have more than one segment in code or data. Then the stack section in this code, it have the value of stack in 100 hexadecimal. In this data section we have declared that data section, and after that we have commented that the data defines go here. Then we are in the main code section. After the code section we have the main proxy, that means initialization of code starting from here, and main end p and end main, that means other process are going from here. That means the main end means the ending of this main function. Now moving on, here are some discussions of BIOS runtime and DOS runtimes. You can go through them, those are not very important for your examinations. INT is for the interrupt number, which is connected with the DOS or BIOS section. Interrupt 21 is to interrupt. By this, here we can see that here we have a single key. Here the function number is 1. Then the single character output, here function number is 2. And then character string output, we have function number in 3. By this you can see that here we have used move AH1. That means this one denotes that the input key function. Here this is the one for single key input. Now 2 is for character and 3 is for character string. Now here we have used 2, so that's why we used here to display characters. We have not used 3 for examples. We will discuss it later. Now the most important diagram is creating and running a program. First of all, you need an editor to create the source program. Then it will go to the .asm file. That means the editor generates the ASM file, which is the assembly file, which will be granted by the assembler, and then the assembly source program is generated, and after that it will delivered a .obj file, and then the linker will take the obj file and turn it into .exe file, which is the running file on the computer, because all the file we run on our computer is the exe file. So this diagram is also very important for your exam question point of view. Have a snap of this one. Those are not very much important, you can skip them. LEA is for the character, and LEA is used to load effect address. Here we have destination first, then the source one. Copy of source offset address into the destination, we use the LEA instruction. Program segment prefix section. Prefix is for fixing the value the previous one, so that's why we use the prefix section. Here we have some example of codes. We are now skipping this one. We will discuss in further slides. Case conversion is the case section of C programming. That's for today. Thank you.